Hello and welcome back to Mr. Bridges and Mr. Reitman. We hope that you enjoyed Mr. Dahl and his wonderful video that he put together in the last lesson.
We're going to move on to our next target, and this is going to be using the zero product property to solve equations.
Okay, so as you guys can see up at the top, we had something that you might have remembered from Unit 1. If not, we'll review a couple of the concepts and everything else. So what this is saying, the zero product property, is if one factor is equal to 0, then we can actually have the equivalent equation, the left side equaling the right side, again trying to isolate that variable and get it by itself, and this time we'll actually have two binomial factors being able to do that. One thing that kids make mistakes on a lot of the time when they see this is they immediately think of, I got to distribute. Because when they see parentheses and numbers, they want to multiply them out.
That would be a big mistake, though, in this instance.
You see the caution. So we're warning you not to do that, which is a good thing. It saves you some time, energy, and you might actually be able to get it right then. So to use the zero product property, we need expressions written as factors. And that's what x minus 3 is going to be called a factor, and 2x plus 5 is another factor. They're binomials, so we're going to think of the terms. There are two of them. So what we're going to do is actually take both of them and set it equal to 0. The zero product property tells us that x minus 3 can equal 0, or 2x minus 5 can equal 0.
Right, you take them separately, and you can make some sense out of all this.
And the idea is, if you multiply a number by 0, you should get
0.
And if you multiply something by, or 0 by something, you should also get,
I would say 0.
0. So this is the idea of doing this. So the first one, x minus 3 equals 0. We just add 3, and we get 3. And the other one is a two-step equation, which you guys should now be familiar with after the last couple lessons. We would subtract 5, divide by 2, and get negative 5 halves, or negative 2.5. You know, if you go with the decimals, right, Mr. Reitman?
That's right. Old school.
All right.
Old school.
All right. So on to the next slide.
Why? Well, we learned this is a good question to ask. Why? You should always ask good why questions. Well, we have these two different pieces here, okay? And we have an x minus 3 piece, and we have a 2x plus 5 piece. And either one of them, if they're 0, we know the other is going to be 0. So my recommendation is find the one that's easier, because 2x plus 5, it's two-step, could be a little fraction involved, but this other stuff on the left side, x minus 3 equals 0, it's beautiful. Beautiful and easy. But there are two different possible values for x, which could make the equation true.
Absolutely. There's two different factors there. You have the one on the left of the left side, the left of the left, and then you have the 2x plus 5, the right of the left side, right? I mean,
the right of the left, yes.
That probably doesn't even make sense. They hate us right now.
Yeah,
but
right.
We do have two possible values for x. There's going to be two solutions that will then make the equation equal the left side equaling the right side. So we're going to try another one.
It's a good idea.
Why not? So go ahead and maybe, we're going to give you 3 seconds to think about it. You can pause if you need more than 3 seconds to think about what you should do in this problem. 1. You counting?
Oh, 2. Sorry.
3. All right. Well, welcome back. So what do we do?
Well, we can take either one of these by themselves. Let's look at one. We have negative 3x plus 1 equals 0. Or you could go 10x minus 7 equals 0. In this case, it does look similar, like we're going to have a fraction on either one, though.
Which is okay. I think we can deal with that. Not a problem. Not a problem at all.
So let's look at the left one first. We would subtract 1 from both sides. We'd have negative 3x equals negative 1. If we went on the right side, we could do 10x minus 7 equals 0. So we'd have to add 7 to both sides. We'd have 10x equals 7. We go to the next step for either one.
What's the next? Is it frozen? Do you guys know what to do?
I think
That's
we're going
right.
to divide, get rid of that
Yeah,
number,
absolutely.
Leave the letter by itself. So we're going to divide on the left one, both sides by negative 3 to get us negative 1 over negative 3. And on the right side, we're going to divide both sides by 10 to get us 7 tenths.
A negative 1 over negative 3.
Yeah.
Negative over negative.
Wasn't there a movie, Stand and Deliver, that talked about a negative times a negative? But this is like a negative and a negative. I don't want to be so negative.
I don't want to be so negative. Hey, let's
make them both positive.
We're gonna make
Be
it positive.
positive.
All right, cool. So you get 1/3 and 7 over 10, or 7 tenths. And hopefully that made sense. If not, it's Mr. Reitman's fault. All right, moving on to the next slide is going to be your chance. Your chance to do these 4. So at any moment, you can certainly pause.
Why don't we pause? Like, no.
And we're
Hey,
back.
we're back.
All
What'd you
right.
guys get for these answers?
Ooh,
Let's
cool.
see.
I'm hoping they get two different answers for this.
It's true.
Now, I'm be curious about 2 and 4 because it looks 2 especially is just an X all by himself. So, but the idea is setting all of them equal to 0. So if X is all by itself, that is a factor.
Really
it's equal to 0. So that's
super easy.
Those are the easiest ones, and believe it or not, those are the ones that kids struggle with the most. So if that was the one you're like, what the heck just happened? Again, we're just setting them equal to 0. So we have X plus 1 equals 0. Subtract it over. These are just one step. Well, sometimes 0 steps. It's just X equals 0. Or a 1 step, add, subtract, or sometimes 2 steps, and get your answers. So check those over. If you have any questions, I would definitely ask one of your teachers. Go to the MARC, right, the Math Academic Resource Center, right by the Ram's Head. I'm in there first hour. Mr. Reitman, unfortunately,
I'm never in there.
Is not in there, I know.
But there's lots of places to catch me, so please do so if you're not understanding any of this.
The
And